problem and told to find the reactions that support A and B. We're also told to assume that the reaction at A is a roller. This roller means that it has a reaction in one direction, and in this case it will be in the vertical direction AY. We also have the pin connected at B, so we have two reactions, the vertical and horizontal, BY and BX. And in this problem, we're going to establish that this direction is positive, this direction is negative, this direction is negative, and this direction is positive. We're also going to establish that the clockwise is a positive moment, and the counterclockwise is a negative moment. Recall that we have our three reactions as we found AY, BY, and BX. We're going to solve for all three of those. Recall that we have our equations of static equilibrium, sum of forces in x equals 0, sum of forces in y equals 0, and the sum of the moments equals 0. But we're going to start with the sum of the moments to find this problem because at B we have two reaction forces, BY and BX, and AY only has one. So if we take the moment at B, we're going to be able to solve for AY. So in this, we have AY equals to the 14 feet, the force in the distance, and it's going to be in the positive direction because it creates a positive moment. Negative 5k in the distance of 14 feet, negative 7k, and again these are negative because they're causing a negative moment because they are in the counterclockwise direction. 2k is going to be causing a positive moment because it's in the clockwise direction, distance of 6 feet, and negative 0.5k because it's going to be causing a negative moment in the counterclockwise direction. So isolating and solving for AY, we have AY equals 7.357k. Now at this point we have one reaction in each of the directions. So one unknown in x, bx, and one unknown in y, by. So we can use some forces in x and some forces in y to isolate and solve for bx and by, right here. The unknown we have in x is bx, and the only other direction acting in x is 0.5k, which acts in the negative direction. Isolating for bx, we solve and find it to be 0.5k. For sum of forces in y, we have ay and by, and we have the negative 5k, negative 7k, negative 10k, and negative 2k. They're negative because they're acting in the negative direction. Ay and by are positive because they're acting in the positive direction. Isolate and solve for by. Since we know ay already, we can substitute and solve and get by equals 16.64k.